It's a navigation problem. The Coast Guard cutter Angelica travels for 30 miles an hour from its home port of Corpus Christi at a direction angle of 355 degrees for 2 hours. We call that leg one. Leg one is a distance of 30 miles an hour times 2 hours. So this is 60 miles. And then changes course. Call this leg two. Direction angle of 265 degrees and sails for 2 hours. Same speed, 30 miles an hour, 2 hours. This is also 60 miles. Okay, probably the most important thing to notice, so we've taken care of all of those other numbers, is the difference in these two direction angles. 355 minus 265 gives me a difference of 90 degrees, which means this is a right angle. Since it is a right angle, that means I have a lot of options. I could just do simple component form and add vectors. That is an option. But since there is a right triangle, I have the additional option of using right triangle trigonometry. So I can use sine, cosine, tangent, cosecant, secant, cotangent. All of these things are at my disposal since I have a right triangle. So let's keep going with the directions. It says to label the vector diagram with the distances traveled in each direction. I've done that. Find the distance and direction angle from the port in Corpus Christi to the ending location of the boat out there in the Gulf of Mexico. Okay, so we're going to pretend like one of those poor sailors that's supposed to be on this Coast Guard cutter woke up late and missed the boat, and he's standing there in Corpus Christi with his binoculars looking out in the ocean, miles out to sea. Where's that boat? Okay, how far away from the late sailor, how far away from him is the boat? Well, since it's a right triangle, Pythagorean theorem will tell us the distance. It's the length of the hypotenuse. So in this case, 800, sorry, there's a decimal in there, 84.9 miles. Okay, that was pretty straightforward. What about the angle? Okay, well, since I know this is a right triangle, I labeled my sides. Opposite, adjacent, hypotenuse are all labeled on my diagram over here. And I know the opposite side and the adjacent side. In this case, I need to find that angle inside the triangle. So I set up a tangent ratio, 60 over 60, and I did the inverse tangent of that to find my angle, which is 45 degrees. So I've got an inside the triangle angle, 45 degrees. All right, so that's the purple angle labeled in the diagram. But the directions did not ask us for an inside the triangle angle as our final answer. What we need as a final answer is what direction angle is the Coast Guard cutter from Corpus Christi. So our stranded sailor here is trying to find what direction should I look through my binoculars to see my crewmates out there at sea. All right, well, 45 degrees is not the direction angle. Right, that's just the difference between the blue vector and the red resultant. So what we can think about is we know that 45 degrees was measured against the blue side of the triangle, and the blue side of the triangle was pointed at a direction angle of 355. If we think about direction angle, we know it started from the positive side of the x-axis, rotates around counterclockwise. If we went all the way around 355 degrees, that's where the blue angle is. But that would be too much of a rotation to see the final location of this Coast Guard boat. So we need to back it up by 45 degrees, which is the inside of the triangle angle. That will tell us our final direction angle. Direction angle. So we're going to have 355. So that is the direction angle of the blue vector. Subtract the inside the triangle angle, which is 45, and we'll get our final answer In this case, the direction angle from port to the ship, 310 degrees.